स्टूडेंट्स कुछ बात करेंगे टाइम डोमेन प्लॉट और फ्रीक्वेंसी डोमेन प्लॉट की। स्टूडेंट्स अभी तक सब टॉपिक्स की डिस्कशन में द प्लॉट्स दैट वी हैव बीन डिस्कसिंग इज अ टाइम डोमेन प्लॉट। व्हाट डू आई मीन बाय दैट? In a time domain plot, we normally plot an amplitude of a sine wave or a signal versus time. Y-axis पे आपके पास amplitude होता है और X-axis पे हम लोगों ने time draw किया था। Students, there are quite a few cases where drawing a frequency domain plot instead of a time domain plot is much more efficient than drawing a time domain plot. Frequency domain plot में we draw frequency on the x-axis and we draw amplitude on the y-axis. So all that we have done, we have replaced time with frequency. Why do we do that? Let's go to the slide and let's have a look at some of the time domain versus frequency domain plots. Students, we'll start with this amplitude of a sine wave which is equal to 5 volts. We have got a frequency of this electrical signal or a sine wave which is 6 hertz. And then because this is a time domain plot, as you can see, we have got amplitude on the y-axis and we have got time in seconds on the x-axis. Students, this is a sine wave in the time domain or a time domain plot of a sine wave. Students, moving on, if we have to convert this time domain plot of this particular sine wave with the same amplitude and the same frequency into a frequency domain plot, then this is how we are going to draw it. As you can see, this is now represented on the x-axis by a single spike, which is at frequency is equal to 6 hertz, and it shows a peak value or an amplitude of 5 volts. So students, you can clearly see that the frequency domain plot is much easier and less complex than the time domain plot. But at the same time, it actually conveys all the information that one can find in a time domain plot. Students, the advantage of this frequency domain plot is that we can immediately see that spike. So we can note down the value of the frequency. In this particular case, it's 6 hertz. And then we can find out the peak amplitude of that same sine wave or the signal as well. Instead of drawing multiple periods, multiple cycles, and a complete sine wave, all that we have to draw is one single spike that shows the frequency and it also shows the amplitude. Students, will move on to another example. And in this example, we can see that we have got the time domain and the frequency domain plots of 3 different sine waves. Students, as you can see, every single sine wave is different when it comes to amplitude. The frequencies are different, the amplitudes are different. The first sine wave has got a frequency of 0 and an amplitude of 15. The second sine wave has got a frequency of 8 and an amplitude of 10. And the third and last sine wave has got a frequency of 16 and an amplitude of 5. Students, you can see the complicated or the complex time domain plot that we have got here. Now, if you convert this time domain plot into the frequency domain plot, we come up with 3 spikes on a frequency domain plot. And you can see the first spike representing the first sine wave is an amplitude of 0. It's a frequency of 0 with an amplitude of 15. It has got a frequency of 8 with an amplitude of 10. And the third one has got a frequency of 16 with an amplitude of 5. So representing a sine wave in a frequency domain plot is much simpler and conveys the same information that is present in a time domain plot, which is a rather complex one.